Assalamualaikum and greetings to my viewers. My name is Wan Azira binti Wan Muhammad Nasir. ID number TJ19077 will explain one of material used in pharmaceutical industry. As we all know, there are many materials used in pharmaceutical industry such as paper, plastic, glass, metal, alloys, and others. Here, I would like to share one of them, which is glass material. Before I start, here are the contents that I will elaborate. We have a quick introduction, type of glass used in pharmaceutical industry, chemical compatibility of glass, method to sterilization, and we also get to know the importance of glass and sterilization. Glass is principally made up of 59 to 80% of silica with varying degree of calcium oxide around 5 to 12%, sodium oxide 12 to 17%, aluminium oxide, barium oxide, boric oxide, potassium oxide, and magnesium oxide. Glass has a high melting point due to the presence of silica. Meanwhile, the presence of oxide changes the melting point and melt viscosity of the glass. Glass is commonly used material for primary packaging because glass is chemically inert and inspection of the content in the container is very easy. For its application, the glass is used to manufacture vials, ampoules, dropper bottles, and jars. In pharmaceutical industry, glass containers are classified into Type 1, Type 2, Type 3, and Type 4 glass based on their degree of chemical or hydrolytic resistance to water attack. Type 1 glass container using ultra-resistant borosilicate glass contains 80% of silica, 10% boric oxide, small amount of sodium oxide, and aluminium oxide. It is chemically inert and possesses high hydrolytic resistance due to the presence of boric oxide. Type 1 glass are suitable as packaging material for most preparation, whether parenteral or non-parenteral. Also, it is useful to store strong acid and alkalis. Glass used in Type 2 is surface-treated soda lime glass, which has been modified to have a high hydrolytic resistance because of sulfur treatment of the inner surface of the glass. This is done to remove leachable oxide from the bottles, preventing blooming and weathering. Type 2 glass has a lower melting point than Type 1 glass, making it easier to shape. For Type 2 glass containers, they are suitable for most acidic and neutral aqueous preparation, whether parenteral or non-parenteral. Type 3 glass container is soda lime glass with average chemical resistance. It contains 75% silica, 15% sodium oxide, 10% calcium oxide, small amount of aluminium oxide, magnesium oxide, and potassium oxide. Aluminium oxide influences chemical resistance, but magnesium oxide lowers the temperature required for molding. Soda lime glass are used as packaging material for parenteral products or powders for parenteral use only where there is suitable stability test data indicating that Type 3 glass is satisfactory. It is used in packaging non-aqueous preparation and powders for parenteral use except for freeze-dried preparation. Also, it is used in packaging non-parenteral preparation. General-purpose soda lime glass container is classifying as glass type 4 with low hydrolytic resistance and used to store topical products and oral dosage form. This type of glass container should not be used for autoclave materials since it will enhance the glass container's erosion reaction rate. Next topic is regarding chemical compatibility of glass and pharmaceutical products. Compatibility means materials are considered compatible with each other if there are no harmful interaction occur between them. It also refers to a material's resistance to corrosion, rust, or stains when it comes in contact with a chemical. Glass is chemically inert materials. It is compatible with many chemicals. For example, hydrochloric, sulfur, nitric, ammonium hydroxide, sodium hydroxide, methanol, ethanol, ethyl acetate, chlorine, hydrogen peroxide, and many more. Method to sterilization. Sterilization can be achieved by physical, chemical, and physiochemical. Physical methods include heat, dry or moist heat, ultraviolet light, filtration, and ionizing radiation. On the other hand, chemical methods involve the use of liquid and gaseous sterilizing agent. Here are the flowchart regarding method of sterilization or disinfection. We have come to last part, which are the importance of glass and sterilization. Glass has been used for decades and it offers a host of benefits. First and foremost, glass is incredibly resistant to temperature. The glass property is highly valuable to the pharmaceutical industry, whose products frequently need to be kept at certain temperatures to ensure that they are not damaged, and their properties remain unchanged. Therefore, glass can be used to maintain the optimal temperature of the product it encases. Next, its high transparency allows easy inspection of contents. It also offers better protection because it is relatively impermeable to air and moisture. Glass is chemically resistant to most medicinal products. Colored glass, such as amber or red colored glass, can protect its content from ultraviolet rays and certain wavelengths. Not only that, but glass is also non-reactive to chemicals. The material will not jeopardize the content's purity even when its outside surface becomes exposed to other products and chemicals. Another importance using glass is it does not leak like certain types of plastic, which can leak a chemical called bisphenol A or BPA. It has been suggested that contamination of pharmaceutical products with BPA can negatively affect the brain and blood pressure. Choosing glass material for pharmaceutical packaging eliminates this risk. Also, glass can be sterilized and face high temperatures without denaturing, destroying bacteria and germs. Lastly, glass has several other properties that give it advantages as a pharmaceutical packaging material. For example, glass is not only tough and durable, but it can also be easily labeled and molded into bespoke shapes and sizes. Next, the importance of sterilization. Sterilization is a critical process in the pharmaceutical industry for the control of microbial population. Along its definition, the importance of sterilization is to prevent contamination in sterilized products, to prevent transmission of pathogenic microorganisms which are responsible for causing disease in plants, animals, and human beings. Also, to prevent unwanted microbial contamination in antibiotic, enzyme, vitamins, fermentation, and other industry processes. That's all from me. Thank you for your time and attention. Goodbye.